Hello all, welcome to Tech with Sas. In this video, we will talk about 12-factor app. 12-factor app is a concept which help us to build the modern applications using the microservices and cloud platform. So if you're looking for the best practices which we must follow when we are creating the microservices, or you want to make sure that your app is cloud ready, so we should follow this 12-factor. So there are 12 factors or 12 standards which we have to think about it before building any application. So like we have this code base, dependencies, config, backing services, build, release, run, processes, code binding, concurrency, disposability, dev prod parity, logs, and admin processes. So these are the 12 important point which are recommended to developers or the DevOps persons so that they are able to build out the modern applications. So let's start with the code base. So code base, like it says that we should have one code base per application, but we can do the multiple deploys for that. So for example, you have a Git branch, right? That is having the master branch, release, and feature branches. So you can track your, you can basically store your code and make sure that your version controls are in place. But when you deploy this code, right? So you are deploying one code base to multiple instances. So suppose you have one application, suppose any e-commerce application, and you should have only one code base for that. And from that one code base, you can deploy it to multiple environments. But there are some entry patterns for that, right? For example, you are trying to split your code into two code bases and deploying it to multiple servers or the instances. So it's not a correct way of having the code base in your application, right? So then also maybe if you want to use the same code base for two applications, so it is not also the recommended pattern. So this pattern basically tries to help us to understand that there should be just one code base for one application, and that should be having the version control. So there should be the branches like the dev branch, release branch, feature branches, and we should track the code based on that and deploy just one code base to the multiple environments so that all environments have the same code and in sync. Second point we have is dependencies. So every application is having dependencies. For example, we have the in Java, we have the pom.xml, which declares multiple dependencies like jars, which are required for the application to run. Similarly, like we have the package.json for Angular. So yeah, so basically, the whatever the dependencies which we require to run or build our application, we must declare them separately. We should not have any dependency which is not part of that separate file, right? So that is how we should manage our dependencies so that whatever environments we are going to deploy, we have just one set of jars. Maybe suppose you are keeping some dependencies as of your application, not in the this config files, right? So there will be confusion. So maybe in developed environment it will be fine, but maybe in production we'll miss something. So it is a good practice that using a dependency file and having all dependencies part of that, and it should not be having any other dependency apart from those which are a part of that config file. So yeah, this is the important point so that we are able to manage all dependencies with correct versions. That's why you must have faced or heard that a developer says, okay, this code works in my machine, but not in the production or development environment. Why? Because the dependency is not properly written down into the config file, and there is a discrepancy between the environment and the local machine, right? Next point is the config, right? So any code, whatever code we are writing, right, it should not be having any config files, because if you are having config files in the code, then they will be changing as per environment. For example, you have database, right? Database URL for local will be different, for dev, for UAT, for prod will be different, right? Because you have to have that user ID, password, or database URL, right? So those will be changing for each environment. So like that, there will be many other properties. So we also always keep the config files in different files, not in the code base itself, so that we are able to modify or able to deploy it separately for different environments, right? So for this, what we do, we externalize all the config files for the environments. For example, for production, UAT, dev, or staging, we will have the separate config files so that they are not part of code base, and also they are not part of the same config file, right? So you will basically externalize those config files and use a config server. So whenever any configuration changes, for example, you want to change to some other DB instance, right? So you have to change that URL for database. So what you can do, you can update this production config file and push to the Git repository. And that is via the config server. It will update to the VM machines or the containers, right? So that the application get the correct or updated endpoints, right? So this is how we can update the config. So here, the concept here is that we should not have the config files as a part of code base. This should be separately tracked and maintained. And during runtime, if there is some changes required in the config files, we should use a config server and we can update the config files at runtime also in the application. Next, we have the backing services. So whatever application we run, right? Suppose we have an app server here, right? That is running some web services or some application. So it will not be just on its own, because it will be using some kind of other applications like app2 here, which it is calling for some data or some resources. Secondly, it must be using some database in case it want to process some data, and maybe also using caching server, that is cache, right? So now these are like external web services or applications which are being called from the app server, databases and caching. All these are the backing services, right? So but there will be some credentials or some URLs or something. They'll be changing for each environment, right? Maybe like this database URL will change from dev to prod to staging, right? So how do we manage those? So those also we manage via config files, right? So we have to maintain all the backing services separately, like we have seen a config factor. So, and basically we have to update your via the config server. So suppose your caching endpoint are changing. So that will be updated for that corresponding environment. And then via config server, you can update it in the runtime. So whatever the backing services, they should be having, let's say, attached resources. So maybe they are not part of your application, but they should be configured in such a way that if there are some changes for those backing services, you are able to absorb it seamlessly. There should not be any code change required. So suppose any app server, any app application or any web service is changing, right, which is you're calling, if something has changed in that, should not need to change in the code base of your code base basically, but you should manage or track via a Git repository and a config server, so that for any backing services, if there are some changes, you are seamlessly updating your configuration at runtime. Next, we have the build, release, and run. So whatever applications we are trying to build, right, it will go through the three stages. So whenever developer commits code to the repository, suppose a Git repository in this case, So then we first do the build, right? We compile the code and generate the artifacts. So, for example, in the Java world, we create either Java or ER artifacts. Similarly, for any other technologies or other tech stack, they'll be creating some binaries or some artifacts, right, which will be deployed at runtime. So all the application code bases should go through all these three steps, right? First, we must commit our code to a version control based code base, and then we should build our code. And after that, whatever the artifacts which we are creating, they should be immutable. So suppose you are creating any var, so it should be having the version, and also it should not be able to change it right after the creation, so that we are able to understand, okay, what is the environment and which is the version is being deployed, right? Then the last step is to run. So these are the three steps which are important and mandatory for the any modern application. Next, we have the processes, right? So it means that we should always use the process as a stateless. So, for example, here you can see user is interacting with the application, and that is basically maybe storing the state of the transaction in database. But what happens in case database goes down or is unavailable, right? So at that time, what happens that the app cannot retrieve the previous state of the transaction. So it is a very poor experience for the customer, right? So the best way is to use the stateless processes so that any transaction which we are performing is independent upon any previous transaction. So the this 12 factor app recommends that either we can use cache or to store any information which we want to use frequently, but we should always try to focus that whatever transactions or processes we are trying to follow in our application, those should be stateless, so that there is no requirement to store the state of the application or transactions, right? Next, we have the port binding, right? So, mostly, like for example, if we have a Spring Boot application having the Tomcat server, so it will be having the embedded Tomcat or embedded server in itself, right? So, your application must be having some port, right? Suppose 8080. But what happens that when you go to the development environment, UAT or production, those port will be changing. So if you want to keep those port into the code base, there's going to be problem, because every time you are wanting to deploy your code into the another environment, you are dependent upon the code base change, right? So for that, what we do, we should have a config file, and that config file should be having the port information for each environment. So we have to make sure that whatever services we are building, either the microservices or maybe also the services which are going to be deployed on the cloud or containers. Those should be having the externalized config files that will be having the port information, so that the application is not having to maintain the port, and also it become very cumbersome in case there is some port change and you want to have the code change, right? So it's better to have the config files for any port related data, and then we can manage the environment, and whenever any port is changing, we can simply update that config file and deploy into the environment. Next is the concurrency. So concurrency means that whatever whatever transactions or users we are trying to basically support, right? So we should be able to scale out, right? Uh, for example, we have a app server, and that is being accessed by the multiple channels. For example, we have the mobile, web, or any other client applications, and then those requests are being sent to our app server, right? But what is happening that those requests are coming in huge numbers. So our app should be able to scale out, right? So that what is happening that we can increase the computing power and memories. Okay, so either you can have that just one server and increase the computing power and memory and try to serve the multiple users. But in case you cannot do that, you have to use the scaling horizontally. So for that, you have to use the multiple servers, right? And those servers will be able to accommodate the concurrent transactions which are coming from the client, right? So basically, we have to make sure that our application is scalable either horizontally or vertically. So that is I mean, so here, right, we are scaling our application horizontally. So we are adding more and more machines, right? So that we are able to support the concurrent transactions which are happening from the client, right? Next, we have the disposability. So now, when we have the multiple virtual machines or containers or pod running, right? So it is really important that we are able to start the application quickly, and also, if required, we can stop the applications gracefully, right? So the main idea here is that suppose you are using the either the Docker Kubernetes or VM or any traditional method, right? So the idea here is that you should be able to start your application very quickly, so that in the global environment you are able to serve your customers faster. And then, in case you want to bring down any instances, suppose there was like a huge demand and you added new machines, right? But now demand has died down or maybe came back to the previous levels. So now you can also shut down few servers or few VMs, right? So for that, the main idea here about this 12 factor app is that the whatever the mechanism which we are using, by which we should make sure that whenever we want to start the application, it should be starting very fast. And then if we require to shut down, right, or maybe stop it, then it also should stop gracefully. So it means that whatever transactions are going on at the moment should not be dropped abruptly. This should be served, and then we should basically clean up all resources or free up the resources, right? Then we should also we should shut down the application. Next is the dev prod parity, right? So normally, like what happens that the developers local machine, dev environment, UAT and prod, okay, they are very different environments, right? For example, developer is like committing some code to a Git repository. Then that code is going through the CI/CD phase, right? You are doing the build, deploy, build and then build, release, and deploy, right? Then you are going to test in the dev environment. So now when the testing is completed by the testing team, then after maybe a few days or a few months or sometimes a few years also, it take the small code change to the production. So it is like a huge time gap between the developer committing the code and that code is being pushed to the prod servers, right? So the 12 factor app recommends that whatever the code changes which are being done by developers, they should be reaching production very quickly, maybe in few seconds or few minutes. It's not like that it's going to take forever to test in dev and then maybe sending the code to a production in after a very some after a long time, right? So the idea here is that normally what happens that DevOps team handles the processes of deploying, right? So the idea here is that the developer is able to monitor or maybe do it itself so that there is no time lag. So the app is such that a developer is able to commit the code and then deploy in the dev prod very quickly. It's not like that it should be taking a very long time, right? So because also so that can happen when all the environment are similar because the developer's local machine and the dev environment and prod environment will be very different. So when we are able to make sure that all environment, right, are same. For example, if we use the containers, right? So container environment will be same because we'll be using the images which are like common to all the environments. At that time, we can make sure that the dev prod are almost same environment, and then we can achieve the faster deployment into production. Right. So yeah, so normally what is happening, these are like gaps which we see. So whatever the time between the deploys in traditional app, we see it might be weeks, but in 12-factor app, we want to make sure that we are deploying in hours. Then the code is authored by developer, but deployment is by DevOps team. So, but the 12-factor app recommends that the same person who developed the code should be able to deploy the code as well into production. And then we have to make sure that dev and prod environments are similar. And so there are few steps we have to take that we whatever the dependencies environment variables we have defined in the same way whatever we have in local dev or prod. So that will bridge the gap between the dev and production environment and it will enable us to deploy our code faster. So now, next 12-factor app is the logs. So every application generates log, right? So like for example, Java, we have log4j framework, and that keep writing logs into the log file. So what 12-factor app recommends that we should basically treat logs as event streams, right? So every log, whatever we are writing is an event, and then that event should be analyzed and consumed, and then we can maybe take some actions as well based on the event, right? So maybe if any application is generating logs, so those logs should be used as a event streams, and then that event stream may be stored in the log stash where we can also then send to the Elasticsearch where we can analyze the logs and maybe action upon with those events, and then maybe those can also be basically analyzed or maybe archived in the Kibana system, right? So basically the idea here is that whatever logs we are creating in the 12-factor app, those should be treated as the event streams, and we have to make sure that they're indexed and properly stored into a server. Like for example, we use Splunk also to store the logs, and from there we can also retrieve the logs and analyze any issues which happened. And also at runtime, we can analyze the logs and action upon whatever is required to make sure app is running fine. So now last 12-factor app is the admin processes. So for any deployment, right? Any deployment, sometime we need to run some processes, right? For example, there would be some DB script to create tables or maybe some migrations or some configurations which are required. Okay. So those should be run from an environment which is like a production environment, right? So because whatever script we are running, those should be running from the prod type environment, not like any dev environment, right? Because whatever script or like one-time processes which we have to do before the app startup, we have to make sure that that is in sync for all environment, right? So for that, suppose developer want to run some configurations before the app is up and running. So those should be part of a script into a repository, and then that can be executed from a prod like environment, and those steps can be done. Like for example, if you want to clear some cache or add something into cache, or maybe some DB migration, those can be done, but those should be done with a proper channel having the proper script. It's not like that somebody going and doing it manually. So 12-factor app is not recommending to do it manually. I will always do via some script, and then we can execute it via jobs maybe. Yeah. So that's it for these 12-factor. And so I think I tried to cover the various aspects of the 12 factor app. So the main idea is that these are the practices which we should follow so that we are able to create the microservices cloud-ready applications which can be deployed into the production seamlessly and quickly and without any manual code change required. So the whole the whole idea here is that whatever application which we want to build, that should be having everything configuration part should be externalized, and whatever the environment we are using like local dev prod, this should be in sync, and any processes which we are trying to do should not be done manually, and everything should remain in sync, right? So that we are able to achieve the quick deployment into the production. So that's it for this video. Thank you for watching. Please subscribe as well. Thank you.